Hi, welcome to my video on review 2 of exponential equations, exponential functions. The video's numbered 15 to 19, this is a review on, and that's the videos pertaining to transformations. And I wanted to do this one as a review just to make sure you knew how to set up a mapping rule and do transformations on the exponential functions. And this review, as all previous, this one is out of 72, so you can mark each question, give yourself a mark on each question, total up the pages, and at the end, see what score you'll have. Here we go. Y equals a, b to the c bracket x minus h plus k. So this is the standard equation where let's find out what each letter represents. Which letter above represents the vertical translation? The vertical translation is the K. So, which one represents the base? B. The horizontal stretch is the C. And the vertical stretch is the A. And the horizontal translation is the H. But when we have this equation, the H is always the opposite of what's here. And the vertical stretch, even though we're looking at C, the vertical stretch is related, the vertical stretch is the reciprocal of the C. So the vertical stretch is 1 over C because it's the reciprocal. When is the basic equation y equals b to the x using the letters above? When is the basic equation reflected in the x-axis? To reflect in the x-axis means the graph is turning over in the x-axis, so that's related to when the a is less than 0. And when you reflect it in the y-axis, that's moving it across the y-axis this way, so that means it's related to when c is less than 0. So if a is negative, it's reflected downward, and if c is negative, it's reflected across the y. And less than 0 and is the negatives. And again, 1 mark for each of these is 5 marks. 1 mark for each of these is 2 marks. State the value of each if y equals 3 to the x is translated. So if we take this basic equation, which has a base 3, and translate it with this equation, let's look at the vertical stretch. So the vertical stretch is the A. So the A is 4, so the vertical stretch is 4. The vertical translation is the K. The K is 6, so that means the vertical translation is 6, so that means it moves 6 up, 6 units up. The horizontal stretch is related to the C, but C is 1. So really, there's no horizontal stretch because C is 1. The horizontal translation is related to the H, and the H in this equation is the opposite. So H is 2, so the horizontal translation is 2 units right. So all points in the basic equation, all points are moved 2 units to the right. And if you have, there's a mark for each of these, so give yourself 4 marks if you have them all right. In the equation y equals 2, 5 is the base, to the negative x minus 1, is y equals 5 to the x, reflected in the x, reflected in the y. So this is the basic equation. So in relation to this equation, this is the basic equation. What is this equation here doing with the basic? Is it reflecting in the x? If you reflect in the x, it means you're making, so the answer is no, because a is 2, and 2 is positive, and because it's positive, it's not reflected. So there's no reflection in the x-axis. In other words, if this was negative, it would make it go down, but it's not negative, so there's no reflection. Is it reflected in the y? Well, reflected in the y makes Notice that the C is a negative 1. C is negative 1, and because C is negative, that means it's reflected in the X. So we said no, reflected in the, sorry, C is negative, so it's reflected in the Y. So if you said no here, you get a mark. If you said yes here, you get a mark, so 2 marks. Total up the page is at a 13. Okay, let's continue. State the transformations on y equals 2 to the x for each of these equations. So let's look at the difference. We know all the bases of these equations are 2, so it's translated from the basic equation with a base of 2. So notice that a is negative 2. Sorry, a is negative 3. As I look at this one, a is negative 3. So because a is negative, it's reflected in the x-axis. Because a is negative, it's reflected down. It's going to go downward. And let's look at, also, we have c is negative 1. So that means it's reflected in the y-axis. Because it's negative, we got a negative here reflecting it in the x. We got a negative here reflecting it in the y. And we have, notice, we have also the absolute value of a is the absolute value of negative 3, which is 3. So it has a vertical v, a vertical stretch of 3. And we also have a 4 here. So that means k is 4. So that means we have a horizontal, k is 4. So we have a vertical, 4 is vertical translation of 4 units up. 4 units up. Notice the horizontal translation would be in the bracket here, but there's no bracket. Okay, if you get a mark 1, 2, 3, 4, each of these right, give yourself 4 marks. And in this one, let's see, we have no negative here, so it's not reflected in the x. We have no vertical stretch. We have no number on the end, so we have nothing to do with the vertical. So we have, notice that c is 6, so we have a horizontal stretch of reciprocal of 1/6. And we have right here, h is equal to 4, which is the opposite. So we have a horizontal translation of 4 right. So notice this is the opposite. So h is 4, opposite of the negative 4. And so plus 4 means it's 4 right. So if you have each one of these correct, give yourself 2 marks. C, we have a negative here. So it says a is negative 1. So that means it's reflected. This is reflected in the x-axis because we have a negative. And notice right here, we have h is negative 7, which is the opposite. So that's the horizontal translation is 7 units left. Because it's negative, it goes left 7 units. And negative 3 on the end, k is negative 3. So that's a vertical translation of 3 units down. Negative means down. So this is in terms of the vertical. So if that's negative, it goes down. If that's positive, it goes up. And again, this is the horizontal. Positive is to the right, negative is to the left. If you have each of these right, give yourself 3 marks. Now, do the opposite of that. Write this equation, which is the transformational form solved for y, for each transformation on the basic equation. So this equation has a base 3. So that means every equation for these 3 is going to have a base 3. So let's see. It's reflected in the x. So reflect in the x, that means that we have reflect in the x-axis. The a is negative. And we have no vertical stretch, so we just have a is 1. because it doesn't say anything. The horizontal stretch is in terms of the c, but because it's 1/4, that means it's a reciprocal of 4. And we have translated 6 units left. So that's 6 units left. That means h is -6. So it's the opposite in the equation as a +6. And we translated 2 units up. So it's a +2. Up is pertaining to the k. So that means up. That means that k is 2, +2. So notice when you do the horizontal, you do the opposite when you relate to the translation. And when you do the horizontal stretch, you do the reciprocal, which is the 4. So 4 marks, 1 for each. If this is the equation, you got the negative, you got the 4, you got the x +6, you got the +2, mark each. Now, number 2, reflected in the y-axis. So if we reflect in the y-axis, that makes the x negative. So the base is 3, and we have a negative with the x, but we have no horizontal stretch, so the x is by itself with a 1. We have no horizontal translation. Don't go left or right. But we do have a vertical stretch. Oop, I forgot to put, let's put a 4 in here. A vertical stretch of 4, so that means that A is 4. Sorry for that. When I made the change, I didn't correct it. That's a 4. And it's translated 8 units down, so it's a -8. 8 units down is -8. So that means K is a -8, so it's a -8. So you have 1 for the 4, 1 for the -x, and 1 for the -8, 3 marks. And reflected in the x and y axes. So again, the base is 3. It's reflected in the x-axis and the y-axis, so that's a negative here, and it's a negative here. Now, do we have a vertical stretch of 9? So that A is 9. Do we have a horizontal stretch? 1/6, so it's the reciprocal of 6. Do we have a translation to the right? So to the right, h is 2, so that's x -2. And 7 up, that means that k is 7, so that's a +7. So the 6 marks, 1 for each negative, 1 for the 9, 1 for the 6, 1 for the -2, and 1 for the 7. Total up your page, 22. Hopefully you understand about the transformation on the exponential functions. Now let's go a little bit further on the videos because they're all in sequence. The mapping rule for an exponential function, the basic graph is y equals b to the x, and then when we do the transformations on the basic equation, the basic equation, the basic ordered pair is x, y, so that's for this table of values. And the x is related to here, but the x is 1/c times x plus h. So whatever c is here, you do is reciprocal times x and the opposite of whatever this number is. And when you do the y, it's a times y plus k. So that's what we're doing. Let's go through 7 is my basic equation. Notice all the bases are all 7. For each one of these, 7 is the base. So x comma y is the base. This is the table of values. This is the table of values for this graph, no matter what you have. So I'll show you when we do a table of values, which I did on previous videos. You put a 2, 1, 0, -1, -2 in. And here we go. Let's look at the x. So that's a 1, reciprocal is 1. So it's an x and opposite plus 1. When we look at the y, we go 2, y plus 3. Now we look at the x again. We get the reciprocal of a half is 2. X, the opposite of plus 4 is -4. So reciprocal, opposite. But when you do the y, you just take it as it is. That's a negative. 1, so it's a negative y minus 2. And here we do the x again, so this is a negative 6, so that's negative 1/6x plus 2. And the y is 1/3 y, and notice there's nothing here, there's a 0, so that's just 1/3 y. When we do the x here, we don't have a bracket, so we got to change the equation. 7, we got to factor out the 2 to make it a plus 3. We have to have a bracket on this expression. Now, when we do reciprocal, if we don't factor, we're going to be in troubles. So now we have it looking like this. So the reciprocal of 2 is a half, and is a minus 3. And right here we have a 1y plus 2. So it's a y plus 2. And again, if you have each of these 3 marks, again you have this one, you have 1 mark, you have the 2 and the plus 3, 3 marks. 4 marks is the 2, the negative 4, negative 1, negative 2 mark each. Negative 6, 2 and 1/3 is and we got the 1/3 and the 0 on the end, so 4 marks. And right here you get a mark for changing it to 2 times x plus 3, and you get a mark for a half, negative 3, and plus 2. 4 marks, 15 for that page. Let's continue. Now let's graph using the mapping rule. The mapping rule is x comma y, and the x's, the reciprocal of 1 is 1, so it's x minus 1. The opposite of plus 1 is minus 1. The y is negative 3y plus 4. Now, this is y equals 3 to the x as the basic graph. So, if you do the basic graph, your table of values is x, y. So your table of values is, the basic graph. Now, see that? I looked at 3, look. The base is 2. The basic graph is y equals 2 to the x. The base is 2. I looked at the 3. Now, the table of values are 2, 1, 0, negative 1, negative 2. 2 squared is 4. 2 to the 1 is 2. 2 to the 0 is 1. 2 to the negative 1 is a half. 2 to the negative 2 is 1 over 2 squared is 1/4. So we take this mapping rule, we put x minus 1 here, and we put a negative 3y plus 4 here. So we take these values and sub it in here. So we're taking 1 off of each of these. So 2 subbed in gives me a 1. And we put 1 in here. 1 minus 1 is 0. So we're going down by 1. So put a 0 in, we get negative 1. Put negative 1 in, we get negative 2. Put negative 2 here, we get negative 3. Now we take the y values and sub in here. Negative 4 for y. Negative 12 plus 4 is negative 8. 2. Negative 3 times 2 is negative 6, plus 4 is negative 2. Now we put a 1 in. Put a 1 in, we get a negative 3 plus 4 is 1. Now we put a half in. Putting a half in here. Negative 3.5 plus 4 is, work it out, 2.5. And we put 1/4 in here. We get a negative 3/4 plus 4, which is 3 1/4. So let's graph these. So when x is 1, we get a negative 8. Right there. When x is 0, we get a negative 2. When x is negative 1, y is 1. When x is negative 2, y is 2.5. Negative 2 is 2.5. When x is negative 3, y is 3 1/4. So there's 3 1/4 right there. So notice the curve is going this way, but notice that in this equation, this is, because this is negative reflected in the x, And because the asymptote is on the end, so the asymptote is 4. So the asymptote moves right through here. The asymptote is always horizontal in an exponential. So this is the asymptote of y equals 4. So this curve is coming up. There it is. It's coming up, up, and now you can see it turning. And when it turns, it will go towards the asymptote, but it won't cut through. So there's the graph. The domain in an exponential, x belongs to the real numbers. The asymptote is the number on the end of k value, y equals 4. And the range is in relation to the asymptote. The range is relation to y is 4, but because this is negative, and you can see the graph is going down, the range, the y values are less than 4, but they're never equal to. And there's 7 marks there. So if you got the basic and you got the table of values and you line them up and you get your asymptote in, you got 1, 2, 3, you get your graph done right. There's 7 marks to there, 7 total. Okay, one more page, and that completes review on videos number 15 to 19. So, one of the videos that we dealt with looking at the graphs and picking out domain, range, and asymptotes. So right here, the domain is always belong to the reals. The domain, don't even have to look. For exponential, y equals b to the x. For exponential functions, that means your range is always your domain, x belongs to the real numbers r. Your asymptote is right here. That's -3, so y is -2. And notice the y values is above the -2. The asymptote is -2, y is -2, but the y values are above that. And right here, the asymptote is y equals 3, but the y values are less than -3, going downward. And for each of these, you get a mark. For each of these, you can mark 3 here and 3 here, 6 altogether. And find the x and y intercepts of this equation. So the x-intercepts is when we let y equals 0. So if we put a 0 into this equation, so we got a 0 gone in. So 0's gone in for y. So now I'll move all these over, move all this expression over here. So that's a negative and make it positive. We divide by 2 and we get 1/3 half x plus 2 equals 9. Now we have, notice we need the same basis. So 9 is 3 squared and 1/3 is 3 to the -1. And that's okay. But we have to simplify this. So -1 times a half times a -1/2 is a half positive. So you notice now that we have 2 same bases, so that means a half to the x plus 2 is equal to 2. Because if the bases are the same, then the exponents are going to be equal. So we multiply by a half times x. Half times 2 is 1. We have a fraction in the equation, so we're going to multiply all terms, all expressions by 2. Multiply, but 2 times a half is x, 2 times 1 is 2, 2 times 2 is 4, and x equals 4 minus 2, x equals 2. So that means when x is 2, y is 0. So we got y is 0, x is 2. So that's the x-intercept. And how do we find a y-intercept? Well, we find a y-intercept by letting x equal 0. So we take the equation that we have here, and we take our time, and we sub in 0 for x. Remember, y-intercept, when it cuts the y-axis, the x-coordinate is 0. So we take our time and work this through. So we work the exponent first. That gives us a 2. So I'll do one step at a time. So a negative a half times 2 is negative 1. And when we have a negative exponent, we flip the fraction. So 1/3 becomes 3 to the 1 power. So that gives us negative 2 times 3. 3 to the 1 is 3. That gives us negative 6. And add that up, y is 12. So when x is 0, y is 12. That's the y-intercept for this equation. And again, if we have 5 marks here, if you get this equation, give yourself a mark. If you get this equation, give yourself a mark. If you get this far, you give yourself a mark. If you solve it out to 2, you give yourself a mark. You get 2, 0 is the x-intercept, then you get 5 marks altogether. And here, if you put y in equal to, or x equal to 0 for the y-intercept, you give yourself a mark. If you work it down to far as right here, you give yourself a mark. If you work it down to far as 12, you give yourself a mark. If you write the answer out as 0, 12, you give yourself a mark. 15 for the page. And if you total up all the pages, and you go back to the first page, and you say, I have a score out of 72, put your mark here, divide 72 into your numerator, convert it to a decimal, move your decimal 2 places to the right to get your percent. And that gives you the how well do you know how to do transformations on your exponential functions. And the transformations on exponential functions are the same as the transformations on most of the functions we deal with. And if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.